How is everybody doing? Today we're going to do something a little bit different. We're going to do more research than actually trying to build something. So we're going to be taking some notes. I recently started using Obsidian, and I want to see if I can take some useful notes in Obsidian that'll help me with the problem that we're trying to solve of, doing chess games as fast as possible. So let's see what we can do here. We're working with a bit of a new streaming setup where I kind of just show my whole monitor and we kind of go from there. So I'm going to zoom in on some stuff here and we're going to see how we can do. So let's get right into it here. Hold on. Let me make this a bit smaller. Actually, I bet I can just have it open in both, and if I update one, it does update in both. Nice. Okay. I like that. Cool. So I can have this open, or I can go down and have it like this, where I can't edit it in this mode, but I could if I changed it to an edit mode. There. Okay. Cool. But yeah, bear with me. We're still learning how we want the layout of these streams to be. If you were here with Cal, welcome. Cal does more gaming content than me. We play D&D together every Wednesday and some Sundays when we can get the gang together. We are playing D&D tomorrow at 7:30 Eastern or 8:30 Atlantic, depending on how you want to slice that. This morning, though, we are looking at Java code, or how to write Java code. I need, you know what, I'll do it in here to start. Or no, I guess this works. Let's just jump right over to here. And I would like to see if anyone has... Okay. Does this have all the different ways? What? No. It definitely does not. Okay. Oops. That's not what I meant to do. One sec. I'm just looking on another monitor here. I don't think anything's really going to tell us every possible way. So this will be an interesting experiment here. Okay, so let's just go through and see if we can find anything about IO and files in this massive wall of documentation. So, oh, this is the JVM spec. That's not going to help. That's not going to help at all. Let's find the documentation. Okay. NIO. Okay. is all the reading shit. Hold on, let's what packages are we pulling those from then? Yeah, Java IO. I guess that's where the exceptions are from. Must be in base, I guess. Yeah, there's NIO and IO. Okay. So let's 87 matches for IO, huh? It's a common word. So let's start with what are the different ways to read files? We've got buffered input streams. We've got buffered readers. And we're going to test all these too. Okay. We'll refine some of these too, so buffer or byte array input stream rather. Byte array input stream. Actually, really, we've only got the file input stream because that's all going to go into one of those. Yeah. The file input stream wraps some other input stream which uses it as a basic source of data. So it's everything with a file input stream basically for the IO. And if we go to file input stream, since Java 1, okay, right, and it's got those read methods. So this is functionally what we're using when we use a buffered input stream. Like when we're in here and we were actually using a random file, random access file is what we were using here, so that's got to be in there too, right? Oh, let's go back to the top here. File filter, file input stream. Okay. File reader. I can't imagine that being quicker. Random access file. Okay, that's all we get in the Java IO world. There's also NIO, but let's keep looking at IO. Instruction, IO. Oh, there's a bunch of different NIO ones. We'll open them all just to take a peek. Okay, cool. Okay. Defines buffers, which are containers for data, and provides an overview. Okay. channels of various types which represent connections to entities capable of performing IO operators. Okay. So then we need a channel. So this is for buffers, and then we get channels. Okay, I don't care about that. Don't care about that. I don't care about that. I think we care about that. I don't think we care about that. Oh. Whoa. Thanks, OBS. Love that. You're supposed to be on this screen. There we go. Sorry about that. There we go. That's all fixed now. Okay. So, why are you still opening on the bottom monitor? I don't understand. Okay, and we don't need this one. So what we're really looking at here is wait, okay, so that's it. Buffers, channels, and these interfaces, I guess, which we might not even need. Okay, so let's take a look here. What do we got? A byte buffer, which is, I guess, what we're, oh, this isn't even that exciting. So I guess we're going to be using a mapped byte buffer, because I don't think, what would be the point of using, no, we'll put them both in there. So we've got we'll just go NIO, and then we'll say buffers. We're going to do a byte. We're going to try a byte buffer and a mapped byte buffer. And yeah, position limit capacity. Okay. I think that's all good. And then let's see the channels. Okay. Can read into buffer. Can read into a sequence of buffers. I don't care about that. Read, write. I don't care about write. Just read. A byte channel connected to an entity. We don't really care about that. Asynchronous we kind of care about. Maybe not. I think we're okay without that. Reading. Okay. So a channel represents an open connection to an entity such as a hardware device. Okay, fair enough. A file, a network socket, or a program component that is capable of performing one or more distinct I/O operations. Okay. Let's go back and let's do buffers again. So where did that make this file? Oh, did that put it where I want it? Did put it where I want it. Okay. Good. Buffers. Okay. defines buffers, which are containers for data, and provides an overview of the... Okay. The NIO package defines the buffer classes which are used throughout the NIO APIs. The char set API... Okay, I know that. I don't want to hear about all the other stuff. Okay. A buffer is a container with a fixed amount. There we go. This is what we care about. So let's... Where's my highlighter? Okay. There. A buffer is a container for a fixed amount of data of a specific primitive type. In addition to its content, a buffer has a position, which is the index of the next element to be read or written, and a limit, which is the index of the first element that should not be read or written. Okay. The base buffer class defines these properties as well as methods for clearing, flipping, and rewinding for marking the current position and resetting the position. Wait. The base buffer class defines these properties as well as the methods for clearing, flipping, and rewinding, for marking the current position, and for resetting the current position to the previous mark. There's a buffer class for each non-Boolean primitive type. Each class defines a family of get and put methods for moving data out of and into a buffer, methods for compacting, duplicating, and slicing a buffer, and static methods for allocating new buffer, as well as for wrapping an existing buffer into an array. Okay. Byte buffers are distinguished in that they can be used as the sources and targets of I/O operations. They also support several features not found in other buffer classes. A byte buffer can be allocated as a direct buffer, which in the case of the Java virtual machine will make a best effort to perform native I/O operations. That sounds incredibly good for what we want to do, right? Like, that sounds like exactly what we're trying to do, which is do things fast. Okay, so it'll do things natively. That's really good. A byte buffer can be created by mapping a region of a file directly onto memory, in which case a few additional file-related operations defined in the... Wait. A byte buffer can be created by mapping a region of a file directly into memory, in which case a few additional file-related operations defined in the mapped byte buffer class are available. Okay. A byte buffer provides access to its contents as either heterogeneous or homogeneous sequence of binary data and any non-Boolean primitive type in either big endian or little endian byte order. Unless otherwise noted, passing a null argument to a constructor or method in any class or interface will cause a null pointer. Fair enough. So, about config and set this to true. Okay. I don't, let's see. Where can I do this? I don't see a way to do that. Okay. Let's do embedded, I guess, and see if that fixes it. Because I don't see another way to do that. And I don't see an about section that I can actually do what the thing says to do, so yeah, let's like that. Okay, well, we can also do it this way, so we're going to scroll up a bit. There we go. We're still learning how to use these tools, so I'm not... Okay. We're going to clean this up a bit here. Okay. And I don't care for this. And what? Okay, how'd that go? That did not go in there. So where did it go? Oh, it's in clippings. Fair enough. Let's get rid of this then. And NIO buffers. Okay. So now we get over here. Good. So Java 20 or now we're gonna do Java doc, IO, buffer, NIO. Okay. Cool. So let's keep going. That worked. Okay, so now we know a bit about what a buffer is in terms of this NIO thing. Which I think we're going to end up using the mapped byte buffer. But can't spell. Buffer. What about a byte buffer? What do we see in a byte buffer? Oh, we get direct and indirect. Okay. So, okay, so mapped byte buffer. So there's no point in even really looking at byte buffer realistically. So let's just jump right into mapped byte buffer. Because, okay, we'll skim this. So, six categories of operations: get put, bulk get, bulk put, absolute and relative get and put. Okay. Byte buffer is either direct or non-direct. Given a direct byte buffer, the Java virtual machine will make its best effort. Okay, so this is what we care about. Direct versus non-direct. Okay. Is that explained in here? Okay. Okay, hold on. Okay, so okay. Let's look at these then. So is a byte buffer then? Does that mean a byte buffer doesn't know? Oh, byte buffer is an abstract. Okay. So if byte buffer is an abstract, does that mean all these? Like, what about char buffer? Does that extend byte buffer? No. Where are the implementations of these then? And what is a map? This is also abstract. Okay, so the channels are going to implement these buffers then. Hopefully. Okay. So let's look at byte buffers then. Okay. Direct. I guess we can just use the clipper here. Unless I can't. Oh, cool. I can just do it with what I have highlighted. Even better. Okay, so I care about a lot of this stuff right now, but that part I do. Okay. Oh crap. How's the coding? Yeah, I'm learning about faster ways to do I/O. Whoa, broken link. Gross. What the? No. I don't like that. Okay, well that was disgusting. Thanks. There. Okay, so a byte buffer is either direct or non-direct. Given a direct byte buffer, the JVM will make a best effort to perform native I/O operations directly upon it. That is, it will attempt to avoid copying the buffer's content to or from an intermediate buffer before or after each invocation of one of the underlying system operations. Okay. So that's important. When we're trying to read as fast as possible, it really sucks to be taking from one buffer to another buffer to another buffer to another buffer to another buffer. So when we were using Java I/O and rummaging around in there, that's all, I guess, non-direct I/O. We'll do a little bit of a dive into that too, but we're gonna have to surmise some of this stuff too. Yeah, we know what a buffer is. And another thing we should be doing too, we should be keeping track of what we're doing here. Researching different Java file IO APIs and implementations. Okay. So let's get back to here. Right. Okay. So, right, direct and indirect. A direct byte buffer may be created by invoking the allocate direct factory method of this class. The buffer returned by this method the buffers returned by this method typically have somewhat higher allocation and deallocation costs than non-direct buffers. The contents of direct buffers may reside outside of the normal garbage collected heap, which is okay. And so their impact upon the memory footprint of an application might not be obvious. It is therefore recommended that direct buffers be allocated primarily for large, long-lived buffers that are subject to the underlying system's native I/O operations. It is generally best to avoid allocate direct buffers only when they yield a measurable gain in program performance. That makes sense. A direct byte buffer may also be created by mapping a region of a file directly into memory. An implementation of the Java platform may optionally support the creation of direct byte buffers from native code via JNI. Okay, I don't really care about that. If an instance of one of these kinds of buffers refers to an inaccessible region of memory, then an attempt to access that region will not change the buffer's content and will cause an unspecified exception to be thrown either at the time of the access or sometime later. Whether a buffer is direct or non-direct may be determined by invoking its isDirect method. Okay. I don't know that we care so much about this, but let's see. Yeah, we know there's primitive types, that's fine. That's for puts, that's fine. Okay. This is kind of cool. This looks like it's probably going to be a bit faster based on what we're reading here, which is all good stuff. What else is in here? So, slice. That's kind of cool. Creates a new byte buffer whose content is shared. Is a shared subsequence. Okay, so I don't quite understand, like when it says shared, is it doing, we'll have to look, but is it duplicating or is it just like new references? Because that's important, but I don't think we need to figure that out right now. Okay, so I think that's okay. And now we can look at the mapped byte buffer, which is still from like still old. This is a direct byte buffer whose content is a memory mapped region of a file. Okay. Mapped byte buffers are created via the file channel.map method. This class extends the byte buffer class with operations that are specific to memory mapped file regions. A mapped byte buffer and the file mapping that it represents remain valid until the buffer itself is garbage collected. The content of a mapped byte buffer can change at any time, okay? For example, if the content of the corresponding region of the mapped file is changed by this program or another. Okay, so like that makes sense. It's not buffered, it's accessing regions of the file as it needs to. Whether or not such changes occur and when they occur is operating system dependent. Okay. So like the operating system is going to schedule the tasks to update the file, and even though you may process the update somewhere, it may not reflect because the operating system hasn't processed it yet, so don't get mad at Java if you update something and it's not reflected in the mapped file. Basically. All or part of a mapped buffer may become inaccessible at any time. For example, if the mapped file is truncated, an attempt to access an inaccessible region of a mapped byte buffer. All or part of a mapped byte buffer may become inaccessible at any time. For example, if the mapped file is truncated. An attempt to access an inaccessible region of a mapped byte buffer will not change the buffer's content and will cause an unspecified exception to be thrown either at the time of access or sometime later. It is therefore strongly recommended that appropriate precautions be taken to avoid the manipulation of mapped files by this program or by a concurrently running program, except to read or write the file's contents. Okay. A mapped byte buffer otherwise behaves no differently than an ordinary direct byte buffer. Okay then. That makes sense. I don't think we need too much on that. Okay, so for this, I think we can actually make a link though. We're going to link to okay. Is a direct byte buffer. And we can just link that out like this. It's got to come back here and go like that. Okay, cool. So that's buffers. now we can move on to channels. Because, I don't know, I don't think we have to look at char sets. We don't. Okay. So channels. What can we learn here? Defines channels which represent connections to entities that are capable of performing I/O operations such as files and sockets. Defines selectors for multiplexed, non-blocking I/O operations. Okay. Oh goodness. Okay. So let's back up a little bit and see if we can surmise some of this first then. Okay. I think the conclusion here is that let's actually go back even further. May as well add this context in here too. Okay. So, oh wow, Twitch is so stupid. Twitch is now telling me, hey, so 48 minutes ago, YouTube said, hey, this dude went live. And I just realized now that I'm using the wrong thumbnail in the YouTube live, but that's whatever, I guess. And just now, Twitch says, hey, if you want to watch this guy, he's live. You're an hour late, Twitch. Quite frankly, if you're... whatever. Okay, so... now we can say, I'm trying to figure out how I want to organize these notes. They're kind of a work in progress here. So we kind of jumped into the NIO stuff because we didn't know it as well. I guess we can just keep going with this for now. We'll have to come back and surmise this, which is fine. NIO channels. Okay. Oh, goodness. Okay. This is going to be an interesting read. Okay, so we read that. A channel, a nexus for I/O operations, can read into a buffer, can read into a sequence of buffers. That sounds good. We don't really care about writing. I'm not really sure which channel is the best way to go here. I guess we'll find out through reading this, but like, I wonder if there's a channel that stacks better with like direct access versus the non-direct access. Because if we're using the mapped byte buffer, because it's direct, you know, it would be nice if there was a channel that just complements that. If that makes sense. You know what? I will change that thumbnail now. I'm kind of jumping all over the place here. I apologize. There we go. Okay. So, a channel represents an open connection to an entity such as a hardware device, a file, a network socket, or a program component that is capable of performing one or more distinct I/O operations, for example, reading and writing. Okay. As specified in the channel interface, channels are either open or closed, and they are both asynchronously closable and interruptible. Okay. Okay. This seems like a good place to start here. So, the channel interface. Let's start there. Which is channel Javadoc. Okay. This is stuff that we just read, so we can safely just chunk that. Like that, bang. Okay. Okay, the channel interface is extended by several other interfaces. The readable byte channel interface specifies a read method that reads bytes from a channel into a buffer. Okay. Similarly, the write... I've misunderstood what's going on here then, because like now I don't really understand how the channels and the buffers work together. If the mapped byte buffer is a direct mapping onto like the native I/O operation, then how does the channel read into the buffer if the buffer is mapped to the file? Oh, okay. Similarly, the writable byte channel interface specifies a write method that writes bytes from a buffer to the channel. The byte channel interface unifies these two interfaces for the common case of channels that can both read and write. The seekable byte channel interface extends the byte channel interface with methods to query and modify the channel's current position and its size. The scattering byte channel and gathering byte channel interfaces extend the readable byte channel and writable byte channel interfaces respectively by adding read and write methods that take a sequence of buffers rather than a single buffer. Okay, that sounds good. The network channel interface specifies methods to bind the channel's socket, obtain the address to which the socket is bound, and methods to get and set socket options. The multicast channel interface, okay, so that's fair enough. I don't care about that. I don't care about that. The file channel class supports the operations for reading bytes from and writing bytes to a channel connected to a file, as well as querying, modifying the current file position, and truncating the file to a specific size. It defines methods for acquiring locks. Okay. A file channel is created by invoking one of its static open methods, or by invoking the get channel method of a file. I think we're going to use one of its static open. Okay. So, to return a file channel connected to the same underlying file as the Java IO class. Selectable channel can be multiplexed. Okay. Multiplexed non-blocking I/O, which are much more scalable than thread-oriented blocking I/O, is provided by sectors, selectable channels, and selection keys. Here we go. A selector is a multiplexer of selectable channels. Oh, that's a sentence. What's a selectable channel? That's too much for right now. I don't need to know yet. What's a selector? Okay, so this a selector is created by invoking the open method of this class. Okay. Selector may also be created by selectors. What do? The key set contains the keys representing the current channel's registration of this selector. Let's keep reading this and see if this is too nitty-gritty. It doesn't make sense yet. I need the big picture. Which in turn are special types of channel that can be put into a non-blocking mode. To perform multiplexed I/O operations, one or more selectable channels are first created and put into non-blocking mode, then registered with a selector. Registering a channel specifies the set of I/O operations that will be tested for it. Okay. Once some channels have been registered with a selector operation can be performed to discover which channels, if any, have become ready to perform one or more of the operations in which interest was previously declared. If a channel is ready, then the key returned when it was registered will be added to the selector's selected key set. I'm not understanding the real-world application of this right now. The key set and the keys within it can be examined in order to determine the operation for which each channel is ready for. From each key, one can retrieve the corresponding channel in order to perform I/O operations which are required. So this sounds difficult then. Like, I don't really understand how you would multiplex and not know what part of the file you're processing, because you don't know which selectors are ready and when they're ready. So I guess like you just can't process anything that requires order or like definedness, like things that you're better off knowing the full size of each record before you start, like each chunk that you want to read. This would be really good, but unless I'm misunderstanding something, I don't think we want to do multiplex or asynchronous yet. So we're still in channels. So that's this here. A channel represents blah blah blah. And how far do we go? Channel. I think we got that from back here, right? Channel flows exception. And these are multi-thread safe. These are thread safe. Okay. And we'll grab this too. Okay. And I think we're going to end up using file channel. Because I haven't really seen any reason not to. Like, I don't... I find it hard to think of how I'm going to use an asynchronous channel here. But so but we can keep looking. Like, where I'm getting tripped up here is, like, if we go back to some of, like let's look at like this file here. This is one of the smaller files. Like, so we've got an asynchronous file channel, okay? Yeah, we can see that. Good. Okay, so we've got an asynchronous file channel, and what we're saying is we want to be able to read from multiple points in this file at the same time. But, like, okay, so OBS, go away. How does that work in practice? So, like, let's say I give, you know, the first part gets to here. How on earth could I ever process a file that doesn't finish the chess game if I don't know where anything else started, you know? Like, how do I define these channels in such a way that I'm not double processing the same thing or wasting IO operations when I could have just processed front to back? If the games were always the same length, or I could easily, like, I guess what you would need to do is you would need to read the byte that you're on, and as long as the byte you're on is not a carriage return, you would have to read forward until you find the next game. And if everything did that, then theoretically you would have everything start at the start of a game, but how would you handle the end? Yeah. Okay, so let's keep reading. I don't know the answer yet, but let's keep learning. Let's keep learning. Okay, so asynchronous channels are a special type of channel capable of asynchronous I/O operations. Asynchronous channels are non-blocking and define methods to initiate asynchronous operations, returning a future representing the pending state. So I know what a future is. I've done some asynchronous. So when you get a future back, basically you can just say, is it done yet? Is it done yet? Is it done yet? Is it done yet? And then you can wait for it to be done. And then when it's done, you can handle it. You can also sometimes do like callback methods. So like when it's finished, it'll kick something off. That's all fine and dandy, but I don't know where I am in the file. And that's really the problem, is not knowing what part, like which future maps to which part of the file and how far off that file is from actually being okay. Or like that portion of the file. So like, again, the part where maybe you only end up with you end in the middle of a game. What do you do, kind of thing. This package defines asynchronous channel classes that are connected to a stream This package defines asynchronous channel classes that are connected to a stream-oriented connecting or listening socket, or a datagram-oriented socket. It also defines the asynchronous file channel class for asynchronous reading and writing and manipulating a file. As with the file channel, it supports operations to truncate the file to a specific size, force updates to the file to be written, to the storage device or acquire locks on the whole file or on a specific region of the file. Unlike the file channel, it does not define methods for mapping a region of the file directly into memory. Okay. That sounds significant to what we're trying to do. So hold on, let me... Unlike the file channel, it does not define methods for mapping a region of the file directly into memory. Where memory mapped I/O is required. So does it buffer? So this is non-direct then. Asynchronous can't be direct. It has to be indirect? Hold on. Then what is memory mapped I/O? Hold on. Whoa, but a mapped byte buffer is a direct access buffer, and says that you can't do that? Okay, so it just lied to me. Great. Okay, so that's fine. So I knew more than the AI. We're good. I was right. And then the AI lied to me. This is why, so like, this is why I hate it when everyone's like, oh yeah, no, vibe coding's the way to go. It's like, no, I just asked it a straight up question. I was like, can I use a memory mapped, can I use a mapped byte buffer with an asynchronous file channel? And it's like, yeah, you totally can. And it's like the best thing ever to do. And then I was like, but wait, you recommend doing this with a mapped byte buffer because it uses, or when I asked it about memory map stuff, it's like, yeah, use this mapped byte buffer, which is, anyway, that was stupid. Okay. I don't think we can make use of this then. Fair enough. So then, I guess we want a file channel. This is the, for anyone new, this is the part of programming that nobody tells you about, which is just going to read the documentation. Okay. So, a channel for reading, writing, mapping, and manipulating a file. A file channel is a seekable byte channel. Okay. Is a seekable byte channel that is connected to a file. I mean, that seems pretty obvious. It has a current position within the file which can be queried and modified. The file itself contains a variable length sequence of bytes that can be read or written, and whose current size can be queried. The size of the file increases when bytes are written beyond its current size, and the file size decreases when it is truncated. The file may also have some associated metadata such as access permissions, content type, and last modification time. Okay. In addition to familiar read, write, and close operations of a byte channel, this class defines the following specific operations. Bytes may be read at an absolute position in a file. Okay. In a way that does not... Ooh! Ooh. That's important. That's really important. This is way more important. Okay. I don't even care or want any of this anymore after seeing that one piece of information. Okay. A region of a file may be mapped directly into memory. For larger files, this is often much more efficient than... Ah! Ah! So much faster! Okay. We're gonna grab this for sure. Okay. So, updates made to a file may be forced out to the underlying storage device, ensuring that data are not lost in the event of a system crash. Bytes can be transferred from a file a.rom to some other channel. Oh, it just links back to file channel. I was hoping it would just go somewhere random, and vice versa, in a way that... Wait, okay, let me read this more seriously. We're talking about optimization again. This should be so much faster though. Even just this right here, and this right here should be so much faster than the native IO, or not native IO, but like the Java IO from Java 1. This should be so much faster. We're gonna figure that out, but that's crazy. Bytes can be transferred from a file to some other channel, and vice versa. Okay. In a way that can be optimized by many operating systems into a very fast transfer directly from one. Oh my god. That's great. That's exactly what we were missing. This is just exactly what we want. That's insane. That's insane. Like, we were trying to use buffered input streams to do all this, and this does exactly what we were trying to do. We're trying to read without changing position in the file. We're trying to break the file into smaller chunks. We're trying to efficiently read in specific chunk sizes to speed up processing. This is all conducive to exactly what we're trying to do. This is great. This is so good. And sure, yeah, we can lock it. It is thread safe. Okay. Close method may be invoked at any time. Only one operation that involves channel position. Wait. Only one operation that involves the channel's position or changes its size may be in progress at any given time. Sure. We're trying to parse as many chess games as possible as fast as possible. So we're building a chess database program for searching and querying large databases of chess games. And the first problem we're trying to solve is importing the games super fast. So we want to take, and we've already we went through and we did like a proof of concept, just kind of mucking around with byte array input streams and buffered input streams and random access files, and how we can kind of get IO to be as little of a consideration as possible. But basically we have to read in a file like this. So this is one chess game, and I've got a file here that's, how big is this file anyway? Let's reveal in File Explorer. So yeah, this file here is almost 500 megabytes. So there's a lot of text in there, I guess is what I'm getting at. And the first thing we need to do is multi-thread the shit out of this. So I need a way to go through this file and say, take this and then go process it. Does the file always fit into memory? No, it does not. To start, like I'm using 500 megabytes as a file, but like realistically, we're looking at 4 to 5 gigabytes. So like you could quote unquote argue that that file fits in memory, but it really doesn't, because the second you start processing it and you start like trying to manipulate that data, your cost of memory goes up really high, because you're probably handling it with strings, and every time you do a substring, you're allocating like a second string. So like it balloons really quickly is what I'm getting at. So what we wrote the first time, we'll kind of go back in time here, is this, and again, this is like, we're early days here, but we've got this concept here of like reading in 8 kilobytes of memory at a time. That just seems to be a good sweet spot where things are really fast, and then looping over them 1 byte at a time to detect things, because byte array operations are way cheaper than string operations. So like when we try to do this with strings, it's exponentially slower because of just the memory allocation and not knowing what size the next string is going to be and trying to like jigger for that. So I've tried it a couple different ways. The first time I did a quick pre-read of the file, just checking for start and end positions, and then I returned a list of start and end positions. But that wasn't really any faster because I was using the Java IO library stuff. It got really hard because the file was so big that I had to use longs as pointers, but I couldn't use longs as indexes in the IO libraries. So I kind of came up against this wall of trying to figure out where in the file I was, because I couldn't just truncate the longs into ints. Then I said, well, let's just find them, and when I find the game, let's just start processing it immediately. But where I'd like to get back to is, which it looks like I'm going to be able to do with this file thing, is I'm hoping that I can just do a quick run through top to bottom, find the start and end of every game, and then from there, once I have those positions, I would love to start a multi-threaded sequence of, okay, grab this chunk out of that file, go process a game. Grab this chunk out of the file, go process a game. So have like a worker thread that's just constantly grabbing a game and putting it onto, I don't know if this is what I'm going to use at implementation stage, but let's just say it's a blocking queue. Just whatever, right? Something for async. We've got some kind of a queue or list that's growing and being taken out of a queue, we'll say. So we've got something that's just going like this, pulling out of the file, putting it into the queue, just like that. And then we've got a whole bunch of worker threads that are saying, okay, as long as there's something, I'm just going to keep parsing chess games. So that's kind of my hope, but we're going for optimization, which is something that I'm I don't want to say passionate about, because like I'm only passionate about it to a point. Like I don't care about squeezing out every last, you know, CPU cycle, but it does really interest me to learn about the various ways of doing it. So like even just seeing the difference between like a buffered reader reading at the line level and then seeing how a, you know, a buffered input stream of processing bytes is like wildly faster, that's super interesting to me. Oh yeah, that's with Marco and Casey, right? Yeah, so I actually started this project before that, but Casey's great. I love Casey. I've watched a lot of videos with Casey. I haven't seen really much of Marco before, but I thought those were really good videos. And I did watch them, and that's actually what kind of pointed me into the direction of being a bit more serious with the research side of it, was just kind of realizing through watching those videos how little I did know about the subject. But yeah, I thought those were really good videos, and as much as I would like to watch them on stream, I'm not a huge fan of reaction content pulling views away from other content creators, so I won't watch them on stream, but I will definitely go get a link and post it in chat, because I thought those were wonderful videos, and I think it's going to be a great series. 1 second here, let me find that. Yeah, here we go. Solving Java's 1 billion row challenge. So for anyone who hasn't seen it, this is what we're talking about. In the billion row challenge, there's a file with 1 billion temperatures in it, and they gotta, I don't really know the whole challenge, but they gotta like read through the whole file, and then they have to like sum up all of the temperatures, I think, and there might be something about highest, lowest temp. I'm not really sure. But anyway, they're looking at how to solve that I/O problem as quickly as possible. For me, I don't necessarily care to optimize to the point that they're going to, but I think it's super interesting to watch. But I would like to get faster than I currently am, and, you know, try to employ some of the best practices, because the end goal here, and this is, we'll take some time to explain this because we are kind of ending soon for right now, but what the end goal here is, we want to make something where, let me see, do I still have, welcome to the human race. What do we got here? So this is a bad drawing that doesn't even come close to what we're doing at the end of the day for the whole thing, but to start, what we're trying to do is parse all these games. The PGN spec is quite frankly terrible. And that's really the problem I'm running into. In the billion row challenge, they've got a nice semicolon delimited file. I don't. I've got a whole bunch of exceptions that I have to code around to try to find the end of the game. So like if we go back to just this game, this section may or may not appear. And if it does appear, there's no set, this is the number of these that will appear. It's a variable number, and also the, I'll say the type, I guess. Well, if we call event a type here, and we call a cool event the value, the types aren't guaranteed either. There are standard types, but it allows for custom types. And then when we get down here, move numbers aren't guaranteed. White space between, so like having a white space right here is not guaranteed. There can also be any number of periods in between. Oh God, you tried to parse a PDF. I'm glad you learned. I'm glad that you, what's the word here? You matured, and now you don't do that anymore. That sounds like that's borderline self-harm, perhaps. That's like trying to parse HTML with a regex. That's bad. Yeah, PDFs suck. You win. You win. I feel worse for you than me now. That's like, the PDF spec is like 5 specs in a trench coat. It's gross. In the end of a game, is denoted by either 1-0, 0-1, 1/2-1/2 for half-half, or a single asterisk. So when I'm parsing these games, I can't just look for ones and dashes and zeros because there's a dash here, there's going to be ones, there's zeros. So like the way I have to kind of find the start and the end of the game is I have to say, okay, well, either I find one of these at the start of the file, which tells me and the start of the file is different than later, right? So if I'm at the start of the file and I find this or this, I know that I'm in for something, but also it could just start with this or it could start with a new line. So we haven't necessarily kicked all the edge cases out yet, but like parsing this sucks. Even just like new lines, like when you download a PGN file, which is what they're called, portable game notation, when you download a PGN file from Lichess, it doesn't use /r/n, it uses Unix new lines, so it's just got /n in there. And because I'm a tool, I'm using Windows, well, mostly because I game, but so there's a lot of shit that I gotta account for in this stupid little read the file. But once we have this, the next step is we have to parse this out into the event and its value for all of them, should they exist. We also, this isn't even a complex one. They get more complex than this. This one here, this is more like, so this is a game that I did play. Did I win? I lost this game. No surprise, I suck at chess. But like, this isn't a move. This is a glyph. Which, yes, I need to preserve, and no, I don't need to preserve. Which is something else we'll have to get into. I need different versions of the game for different parts of the program. So, yeah, that's gonna get weird. This is an annotation, so like everything between that curly brace and this curly brace is a comment. And these here aren't part of the move. They're also just like commentary marks. So like all of my commentary marks here, I need a way that I can access them, which like I have a loose idea in my head of how I'm going to store that. But like I don't know how I'm going to parse it into like a Pojo or some kind of like useful deserialized object that I can carry around. Because that's the same thing with these. These things in parentheses are called like secondaries or additional lines. So like if I go to Lichess, I am still signed in. Good. So let me go to my studies. Also, I'm going to say this now. I suck at chess, okay? This is not a I'm good at chess stream. This is a I'm interested in chess and I really like doing programming stuff. This is the game that we're looking at. So right here. So knight g5. If we look down here, these are the moves that I propose to play instead. So like when I played this game and I lost, I wish I had a better study. Because I don't think I was sure I commentated some of this. I was like absolutely sure that at least one of these games I had done an actual written thing for. But maybe not. I was certain that I had more commentary. Did I do some in here? Oh, cool. Look, I won this game when I was 270 rated. Anyway, we'll go back to this game. But at knight g5, what I'm saying is this is an inaccuracy. Probably what I should have played was d4 or knight c3. Because, what did I say? This move is inaccurate. My knight is moved for a second time during the opening. arguably to a worse square. My bishop and knight are both attacking a weak f pawn. So like, just bad stuff, right? But there's also something else too that we need to look at, which is, I don't know where somewhere in here there is another type of data that we need to be careful about. Is it on a sideline? I think it is on a sideline. Okay, is it on a sideline of 4? Let me see. Not that one. There we go. These arrows are also in the PGN file. So if we go back to that file, we can actually see these arrows in the annotations. Right here. So this is a yellow line that goes from the coordinates C1 to G5. So if we go back to the game here, we can see that there's a line from C1 to G5. And then over here, there's a red one from G5 to E4. We won't do them all, but from G5 to E4, right? So I need that sometimes, but not all the time. So here's the thing. I haven't looked too far into it yet, but that a lot of the stuff isn't in the spec. So that's kind of the problem. The spec is very loosey-goosey and kind of allows, it's got a general form, but like these lines are not part of the spec. So like if we go look at the spec here, the spec is really fundamentally, when we think of the spec is really just this, and anything outside of this isn't covered by the spec, more or less. So that's kind of the problem we have. Even like when we look at like chess.com versus Lichess, they don't even consider PGN the same. And when we look at the other, let's say competition, right? Because I'm making this app, there are other apps that do this, but like the competition is really, I'll narrow it down to 3. There's more that exist, but there's 3 that I know of that I would consider good, 2 of which I've used. The third one I haven't because of its absorbent cost. But we've got Skid versus PC, which is really old. Kind of, but realistically, all we really need to do is support Lichess and chess.com. And if we support Lichess and chess.com, that's a really good start. And anybody else who has their own PGN is probably converting from a proprietary. So like when I start talking about these guys here, it'll become a bit more apparent what we're talking about. But if we can get the 2 major chess websites and then just like kind of drop the stuff that's non-compliant from those, I would consider that good enough. So like if I can parse a Lichess PGN and I can parse a chess.com PGN, as long as I can suss out what's wrong with the other ones, I'm okay with dropping the things that are non-compliant. But the 3 competitors things that I would consider competitors to this app would be Skid versus PC, which is very old and outdated. I don't know how it does its line annotations, but it's also got a proprietary database format that's not PGN, but it can export to PGN. Ideally, I would like to try to reverse engineer the Skid versus PC database format and try to allow direct imports of Skid versus PC databases. We've also got En Croissant, which is a newer one. I really don't know what it's going to take to handle anything from that. I don't know really anything about it other than I used it a little bit as like for chess study. But I never really looked at what it puts out or how it formats or whatever. And I'm not necessarily concerned about being compliant with that because that's a fraction of a fraction of a fraction of the market kind of thing. 90% of people are using Skid versus PC or ChessBase. ChessBase is the professional grade software, which I think that we can just absolutely destroy from a performance perspective. And it costs like $300 or more. And their database, you got to keep buying updates to it. But the thing about Chessbase is they source a lot of games. But that Chessbase format, I believe, has already been reverse engineered. The substance of their proprietary format. So realistically, because I'm targeting the SCID database files directly and the Chessbase database files directly, portable game notation is just kind of this in-between state where websites will use it, and people may, enter them online into random things and get them out, but they're probably not hardcore annotating them if they're doing that. So to get where we are, what we want out of this is, if we can, I lost my train of thought there. If we can just parse Lichess and chess.com, that's good enough here. But yeah, if I wanted to hit everything, I do think that would be kind of borderline impossible. But the couple of things here to note that are ubiquitous and everywhere. These are everywhere. These are glyphs. They're known glyphs. We can find those. That's going to be standard. This denoting a comment is standard. There's also a full line comment, which is just a semicolon. However, websites like Lichess don't do that. They like to put games on full lines, but not every website does. So you'll probably, I'm going to say probably, because I can't say for sure, but you'll probably never see a Lichess PGN that uses a semicolon. Because if I were to put a semicolon here, oh, what am I doing? If I were to put a semicolon here, what is... I'm in normal mode, come on! I'm also trying to learn Vim. Oh, Jesus. Scroll back here manually. So, if I had a semicolon here, that would mean everything after the semicolon is a comment until the next new line. You'll probably never see that in a Lichess PGN because all their games are single line regardless of the length of the game. But this denotes a comment, and if you put a semicolon inside of this, it doesn't do its regular function of terminating to the end of the line. Instead, it's just part of that comment. So this is the braces, standard practice. These are standard practice. ... usually means white's move was back here, which it was, bishop c4. Oh, that would be super useful. Yeah, good job. Thanks, chat. That's going to save me a ton of time. We've got so many things to learn. Unfortunately, for work, they force us to use Eclipse. So while I do use VS Code, I don't use it a ton for Java. So we're kind of like really out in the middle of nowhere in terms of like all I really know is like how chess works, and I'm gonna say I'm decent at Java. I don't know. We'll let you guys decide if I'm good or bad, but I consider myself better than other people and worse than a lot of people. Somewhere in the middle of the pack, probably. But we got a lot to learn. So far, all this is pretty standard, except this. Now, if we go back to the PGN spec, where... Somewhere they come. There we go. These are an escape mechanism. In the first... Okay, so that's not going to work. Is this for nested annotations as well? Is that why? Delimit tag pairs. Best moves. I only... One sec. Sorry, I'm just dying. Only once, theoretically. So the idea is when you import a game, we're saving it to a Postgres database. So the files themselves, I only have to go through them once. But you can continually add files. So like if I add a 4 gigabyte file, in 10 minutes I might add another 5 gigabyte file, or I might not, or I might add 100 1 gigabyte files. It's really unknown. Each file may or may not contain one or more games. Because like even in this this spec, they even say that like some files might be empty, and that's okay. It's just uninformative. So if that's the okay, so inside of a comment, if I find these square braces, we can use this % to say this is dumb. I feel like that is normal, and chess.com does something similar, but they use different words. Like instead of cal, they use something else. I don't know what cal means. Maybe it's color align. But I think that's really all we care about. It's also worth noting, so like, and this is probably, we'll probably end in the next 15 minutes here after this discussion, so we're kind of winding down now, but kind of where I expect this to go is there's going to be, if we kind of dumb it down a bit, I'm going to say multiple databases. I haven't decided that. This might be one database with multiple tables. It might be 2 Postgres databases. It might be a Postgres database and a NoSQL database. I don't really know yet. I need to do more research into what fits this use case. But for now, I'm just going to say 2 databases. Just because that's how it's organized in my mind. I've got a reference database, which is for searching. So it's for finding, comparing, and doing complex ideas. And then I've got the other side, which is another database that's for annotating, editing, and studying. So when we think about this, what I'm saying is that one part of the editor is kind of like this, where I can like come in here and I can edit this. So like if I were to go, that's not what I want. If we go here, we just make a new study, we create a chapter, and I go like this, and that was dumb. So like there's going to be a part of the application that kind of does this, where it's like you can just kind of come through and annotate your game, right? And I can, that was dumb. Let's put a glyph on that for what a blunder, right? What a blunder. Black is now winning somehow. So part of the application is going to be this. And these PGNs, I kind of want to store in a NoSQL database, where it's like, it's kind of more like whatever you kind of put there just kind of gets slurped off. I don't really care. It's not really indexed. You can't really search it. But I also want to mirror this game into a more performant database where I can do super complex things like, for instance, let's just go to watch current games. Let's just go to a random game. I would also like to say, in this position, how many chess games are there in my database in this exact position? Now, that kind of seems trivial, right? Like, but think about it for a second. What do we have for data? We've only got a move list. I can't compare the move list because that move list is not the only way to get here, right? So there's more to it than that. So that's why I've kind of got this idea of two databases. One database is going to have to be indexed in a completely different way, in a very performant way, because we're talking about, like, let's say 500 million rows, right? Because we're talking about many millions of games with an average of 40 moves per game. That also means there's an average of 40 positions per game. Another thing I should probably bookmark here anyway, so we'll get right there, is Fen notation. So Fen notation is going to be super important for us. So we'll bookmark this now. Fen notation is, can I have an example? So so give me a better example? No? Okay. So Fen is in up to 95, I think, somewhere around there, 95 character string that denotes the entire board state. It knows castle rights. It knows if en passant is a factor. It knows whose move it is. It knows where every piece on the board is. It knows everything based on this one string. So the goal here, in my mind, is to say, let's take that Fen string, all 40 of them, and let's hash them. Let's hash the Fen string into something that I can compare even quicker. And then we're going to have some kind of data organization that will allow us to index those Fen strings. So when we're doing our searches on, 500 million rows, we can also keep a log of which exact hashed Fen positions are actually there. The other thing we can do to drastically speed this up is to start caring about the material. So when we're talking about material in chess, every piece has a point value. For instance, pawns are worth 1 point, rooks are worth 5 points, knights and bishops are worth 3. The queen's worth 9, and the king is worth the game, so don't bother assigning a point value there. But the point here is that if I know in this game, let's go back to the game, we got, what's the points? 1, 2, 3, 8, right? 11, 20. Oh, and then 29. So 29 for white. So we can add that to our query too. Immediately on first search, we can say, I only care about Fen strings where the material count is exactly 29. And then that immediately gets us down to a subset of the possible rows. It also gets a bit daunting when you start thinking about, like, just... Here, hold on. I'm going to change my view here since we're ending off here. So, what I was getting at is, numbers be big. The number of possible chess positions is like 10 to the 44. Like, it's an obscene amount of possible chess positions, right? So the sheer amount of possible things really makes this a daunting task to take on when you start thinking about all the possibilities and how you're going to handle them. Like, even just hashing things like my Fen strings, that theoretically means that there are 10 to the 44 possible valid Fen strings for me to need unique hashes for. So I need to pick a hashing algorithm that's going to be performant, but also handle very large numbers. But I hope you guys who tuned in today found some of this interesting. We're doing a lot of reading, and we're going to get there. That's kind of why, I guess I'll go back to the all view for a second here. That's why I'm using Obsidian now. I'm going to start taking good notes. This is all we did today. So we can actually link that right here. We'll say reading data as fast as possible. That's all we did today. That's fine. You know, I'm probably going to do some stuff offline too, but we went through, and this is, you know, kind of stuff that we already used, so we didn't start researching there. I'm going to go back. I know I'm not going to use it, but I'm going to go back. I'm going to refresh myself. I'll do the reading. I'll do the homework. I might do these ones off stream. And right now we're looking at the Java NIO stuff. But yeah, we're going to learn how to do this properly. It's just going to take some time. It's all just time. So back to browsing. Research is important. A lot of people get into programming and they don't realize how important RTFM is. Read the fucking manual, right? A lot of people don't do it. I probably didn't do it too. It's a big part of the game though, right? A big part of my throat's getting dry now, but it's a big part of learning, is learning how to consume these documents, right? So like before I started today, like, yes, I did watch that video with Marco and Casey. I didn't remember what any of the APIs were called though. I just remembered that there were better APIs out there. And then that took us into, like, we've still got all these tabs open. We started here. And then we went into Java Base. We looked at Java IO. We looked at NIO, which is somewhere in here. NIO. And, you know, at some point we'll eventually get to, we're using Java 24, so eventually we'll get to, there's a third one in here that was introduced in 2024. We're also going to look at that one too. I don't remember what it's called though. We're going to just try to find it. Isn't Lichess open source? We can definitely do that, but kind of the problem I'm having right now is processing them as byte arrays. It's not so much, I'm not at the point yet where understanding the format is the issue. It's getting into things like when you're reading 8 kilobytes at a time, how far do you have to back buffer to be useful, and when do you convert to string? So I've also got enough of my own personal chess games that use all of the Lichess features that we can probably just figure it out by looking at the games. But you're totally right. We can go look at that too if we need to. Lichess is entirely open source, which is great. Also, maybe I never finish this. Maybe I get like my own personal joy out of it and I never come back and finish it once I feel fulfilled or whatever. But assuming I do finish it, I plan to open source this as well and make it a free open source alternative to ChessBase, assuming I can ever get it working. Because I think that's cool. I think open source software is really cool. I really like the idea of not everything being SaaS. Not everything needs to be a service, and I'm getting really fucking tired of paying for things that I used to own. I'm getting real tired of it. Like, if you need cloud storage or compute time, like I kind of get paying for the compute time, and I kind of get paying for the storage, but like, just give me the option to not have to do that, right? Like, don't make me use your server. But then there's less money in it, right? Nobody likes to not make money, apparently. Yeah, my hope would be to release this and then just, I don't know, make a coffee link or something. If people want to give me $2 or $3, that's cool. But especially for like games like chess, where like it's in the public domain, like I don't know. There's nothing proprietary really about what things like ChessBase do. It's just all about how they serialize their data and store it, right? So you could argue that there's something proprietary there, but there's not, right? Like, they're using an open spec of PGN. They're using the public domain rules of chess, the name of chess. there's nothing implicitly special about what chess-based does other than no one else has really put the work in to make something fast and performant to rival them. Other than Skid. Skid was pretty good, but Skid's like 30 years old now and like is basically just kind of held up by willpower. It hasn't been maintained in a really long time. So not only does it look really old and grouchy, it kind of is as well. And it's opaque and hard to use, but also so is chess-based. Like, Jesus Christ, chess-based is also opaque. Menu upon menu upon menu just to do like a simple thing, and then you gotta wait like sometimes 20 or 30 seconds for like your query to run. It's like, Jesus, there's got to be a better way to index that data. Like when we're talking about small rows, like again, like these fen strings are less than 100 characters and we're gonna hash them. That shouldn't take very long to compare, even at millions of rows. Even on Postgres, even on a laptop, right? Like, obviously, the lower you scale the hardware, the longer it's going to take. But, like, on a good computer, I feel like most of the queries I plan to run or write, I should be able to have done in a second or two, right? Like, especially with multi-threading. Like, the way I plan on hammering this Postgres database is, like, go get me the first. I'm going to make up numbers. I don't know what numbers are going to be performant here. I'm going to make them up. But the idea is that we will tune them to be performant, right? So what do we got? So when we're hitting Postgres, we're going to say, give me 1,000 games. And as I'm comparing the games, I'm going to store the ones that didn't match. So when I do the next query to get the next 1,000 games, I'm just going to ignore those hashes outright and not even bring them back. And then basically every time you say get the next 1,000, get the next 1,000, you're just slowly weeding out the amount of things you even need to consider. So like as the search goes deeper, it should, we'll see when we get into like Postgres and optimization, what I would hope to see is as the search gets deeper, it actually gets more performant because it's actually weeding more things out on retrieval. So your first two hits, which again, you're only bringing back like, again, let's say 1,000 at a time or whatever we can do in a quick amount of time. After that first one, you're already weeding out future things that aren't going to match. So there's that. Yeah, I hope you guys enjoyed that. This was like 2 hours of research today. I'll probably do some research offline too. Not all the research will be done on stream because there's a lot of it that needs to be done, but we will do our best. And hopefully, the first thing we want to do, we just want to parse these games. If we can parse these games, then we can start designing a database, and that's where the fun really begins. Arguably, we could start with the database, but this is just more fun. This is just more fun. At least to me. Other people might not see it that way. I think this is a lot more fun. But that's it for me. You guys have a good rest of your day. I'm just realizing now I don't have a stream ending screen, so you guys can get the technical difficulties screen for a couple minutes here. And I'll see you guys later. If you liked this, give us a like if you're on YouTube, or a subscribe. Give us a follow on Twitch. We also do D&D and gaming content. Tomorrow we'll be doing some D&D. There's also D&D every Wednesday. So some Sundays, depends on when we can get the group together. Every Wednesday we got D&D. And there's also gaming content from another guy on the channel. His name's MC Calamity. He plays a bunch of games right now. He's playing through the Neverwinter game. What's it called? I should know this. Neverwinter Nights. That's it. Neverwinter Nights. So he's playing through Neverwinter Nights. I'm doing Java programming. We're both doing D&D. We got a lot of stuff. So if any of that interests you, we will see you hopefully next time. Have a good rest of your day, guys.